Alright guys, so I'm going to solve problem number 2. It is very useful if you try problem number 2 on your own and then fill in the gaps using this video. Just copying this, just following me and copying this is not going to help you at all. So you should try it on your own. Even if you feel lost, try it on your own or even look at the previous work. In this, give it a shot on all the problems and then come back and watch this video and see whether or not you made any mistakes. So we're going to begin. Notice that anywhere that says BCA table, okay, I already created a BCA table. It's just, you can pause now and create your BCA tables if you haven't done so. Alright, the first step in solving this problem is actually reading the problem really well. So it's asking for how many moles of oxygen. So let's find oxygen. Oxygen is right here. So how many moles of oxygen are needed with excess sulfur dioxide? This is telling me that this is in excess. There's a lot of it. Okay, so this is going to be the limiting. So this is going to be the limiting reagent or limiting reactant. So to produce 10 moles of sulfur trioxide. So I'm going to produce 10 moles of this. Okay. Why did I put this here? Well, this is after the reaction, right? So the product can only be produced after the reaction took place. So products are only going to go down here. That means that before the reaction, there should have been no product, right? The same thing here, this is in excess, so you're going to have some left over here, which is irrelevant to us. However, this should be 0 because this is the one that's holding up the reaction. Alright, so I hope you're able to follow this thought process of how to fill this out. The other thing I want to bring up to you is that the problem is going from moles to moles, so you don't need to worry about molar mass or grams or anything like that. You can go straight into the BCA table. Right. So we need to begin with the information that was given to us. So you were saying that 10 moles of the product was formed. So the product is per 2 molecules of sulfur trioxide. We need to figure out per 1. The way to do that is during the change, the 2 is going to go here, and this 2 belongs to this, and it's going to be 5. Okay. And why 5? Well, because 2 times 5 is 10, because there's 2 molecules of it. So the 10 molecules is for the whole thing, but you need to know individually. Okay. I mentioned this before, but I'll mention again. Whatever's in the parentheses must be the same for all of them. So this is going to be 5, this is going to be 5. And you don't need actually to put the unit moles because everything here is in moles. Okay. We do need to be worried about the coefficient. There we go. This coefficient comes from the balanced equation. Alright, so now we have our answer, because if we look at oxygen, this is what the problem is asking for. How many moles of oxygen, right? Well, that will be 5 moles. 1 times 5 is 5, so 5 moles. Okay, so the answer to your question is 5 moles. Alright, let's look at the second problem. How many grams of sulfur trioxide will be produced from 2.5 moles of sulfur dioxide? Alright, so let's go slowly. So it's asking for grams of SO3, but I can't determine the grams at this point. I can only determine the moles. Okay? And this is what I'm looking for. What's given to me is 2.5 moles of sulfur dioxide. The assumption here is that this is the excess. Okay. And like I mentioned before the reaction, there should be no product. And then after the reaction, this is going to be 0, and this is the excess. Okay. So looking at this, we have 2 molecules of sulfur dioxide. I need to know per 1 molecule of sulfur dioxide. So this is a 2. Okay. And this is 1.25. Because 2 times 1.25 is 2.5. The parentheses must be the same. Okay, and then all we need to do is put a 2 and a 1 in here. So after we finish completing the table, we need to go back and read it again. How many grams of SO3 will be produced from 2.5 moles of SO2? So 2.5 moles of SO2 will produce 2.5 moles of SO3. Okay, because 2 times 1.25 is 2.5. We are not done, so we're here, but we are not done with the problem because the problem asks for grams. So we need to convert this to grams. 2.5 moles of SO3. Every time we need to convert from moles to grams, grams to mole, we need to look at the periodic table for molar mass. I know if I do my molar mass correctly, I get 1 mole of SO3 equals around 80 grams of SO3. And multiply this times this, so 2.5 times 80, and I get around 200 grams of SO2, or SO3, sorry. Moles cancel with moles. My unit is grams of SO3, and that is the answer to this problem. Alright, last problem. The problem is asking for how many grams of oxygen gas, so it's asking for this. I needed to exactly use up 2.5 grams of SO2. So what the problem is asking is, if I don't want to have any leftovers, how many grams, and I start with a certain amount of SO2, how much of oxygen do I need to use? It's a fair question because we don't always want the leftovers mixed up with our products, right? So we want to, ideally, we want to have the same amount of both, so there's no leftovers. So in here, it's giving us grams, and we know that we cannot put grams on a BCA table. So before we do the BCA table, we need to convert grams to moles. So 2.5, right here from here, 2.5 grams of SO2. Okay, again, using the molar mass, I have 64 grams of SO2 equals 1 mole of SO2. So grams cancels with grams. 2.5 divided by 64 is a very small number, is 0.039 moles of SO2. Now I can take this number and put it on the table. And when I do that, I'm going to end up with this. This is what I want to know. I know that this has to be 0 because before the reaction there should be no product. I know that both of them are going to end up with 0. That's the whole purpose of the problem. This information I don't need to know. That's not what the problem asked. So I don't need to go there. So all we need to do is figure out what's changing. Well, this is the total amount. I need to know per molecule. So this number divided by 2 equals 0.019 approximately. I know whatever's in the parentheses is going to be the same. Okay, the coefficient is 2, the coefficient here is 1. Alright, so my table is completed, and based on this table, I know that if I multiply this by this, it's going to give me this number, which is 0.019. So in order for this reaction to not have any left over, I need to use 0.019 moles of O2. However, that's not what the problem asks. The problem asks for grams. So as you might be able to guess, we need to go from moles to grams. 0.019 moles of O2, 1 mole of oxygen equals 32 grams of oxygen. Mole cancel with mole. 0.019 times 32 equals 0.625 grams of O2. And that is the end of your problem.